Welcome back to the Scotti-BYTE channel, and this is Scott. So today I want to talk about what happens if your Ubuntu server disk gets too small. So in LXD step-by-step, we built an Ubuntu server on which to host LXD containers. And I also have a video entitled Cheap Self-Hosting Server where I used a Minis Forum UM350, which is a small mini PC that has a 500 gigabyte NVMe disk by default on it. So the Ubuntu server had the root file system on an M.2 NVMe drive, and it used Logical Volume Manager, or LVM for short. In my discussion forum, I have an article entitled Moving a Linux Server to a Larger Drive that I published last year in November. And I used the data duplicator dd command at that time to copy a 512 gigabyte NVMe drive to a bzip2 compress file, and then I restored it to a new 2 terabyte NVMe drive using dd again. And the reason I went through that process was that I did it on my desktop PC, and in both cases I put the NVMe drives in an external enclosure. So dd works, but unfortunately it's rather slow. So in the original process, I used dd to create a bzip2 file on another computer, my desktop, by copying the NVMe drive in an external enclosure. And next, I put the new drive in the enclosure, and I used dd to do the restore. So pretty simple process, it's just that it is a multi-step process. So the downside was that I had two separate copy commands, and also dd copies all of the blocks on the drive, whether they're used by files or not. So this time I installed the new uninitialized unformatted drive into the actual server, and I put the old NVMe drive in an external enclosure, and I used Clonezilla to copy from the old drive to the new drive. And Clonezilla moved about 272 gigabytes in 7 minutes with the external enclosure connected to a USB 3.1 Gen 2 port. And the advantage of Clonezilla is that it only copied the actual files and not the unused blocks. So after the transfer, I had to enlarge the ext4 file system for the LVM partition. I had to extend the LVM partition and finally resize the LVM file system in order to see the space in the root file system. And so here's kind of an example, and in this case, since I have the drive, the old drive, mounted in /dev/SDC3, that's what the LVM partition is for the root device. And if you look very carefully here, I said that 270 gigabytes of it was used, but here it says that there is a 472 gigabyte partition and 474 gigabytes are used. The reason for that is because LVM is using the entire, or the ext4 assignment to LVM is using the entire space. But as far as the actual LVM partition, it's using less than that, and that's what we want to talk about today. The disk that I've been talking about is this 512 gigabyte NVMe drive, and that was what was in the Minis Forum UM350, and so this is it inside of the external enclosure, and of course that's what we're going to be talking about now. So in looking at VMS Mist, so VMS Mist is one of two UM350s I have, but this particular one had that 512 gigabyte NVMe drive in it, and I had gotten to the point where I really wanted to expand it, and I had the available 2 terabyte 980 Pro available, so I went ahead and swapped it out. If we do a DF here on VMS Mist, this is after I've swapped it out, but right after I did the clone, if I came in here and took a look at this root device, which is the LVM, it still looked exactly like it was a 512 gigabyte disk. I published these show notes a year ago when I had done the original migration to the larger drive in VMS Rain, which is the UM350 that has my larger applications on it. And so it's been running a 2 terabyte drive for a while now. And this document here, I'll go ahead and link as the show notes, and it describes moving a Linux server to a larger drive, as it says, the subject of this video. But you'll see in this document that it talks about DDing the drive over to a file on a computer, and then taking that file and restoring it to another drive, which is what I did. But that was very slow because, of course, DD had to copy all of the blocks, and also I had to do 2 copies. One to go from the external enclosure to a compression file on my computer, and another one to go back the other direction. So you don't need to necessarily do that. You might be wondering why you don't just do this live on the system that you're working on, and the answer is you really can't have the system mounted while doing these sorts of operations. So what I did was I took the UM350, I put the new 2 terabyte drive in it, I put the old, or I should say current, 512 gigabyte drive that I just showed you in an external enclosure, and then I went ahead and booted from a USB stick that had Clonezilla on it. And so that's pretty much how I did that operation. In any case, when I did the first operation after having done that last year, the next thing I had to do was to do an LVN or an LV extend to go ahead and resize the LVM volume. Unfortunately, that didn't work on the new system because it didn't think that it had any space to expand to after Clonezilla was done doing its job. And in fact, when I did the LV display command, it also showed me that the LV size was only the 512 gigabyte drive and not what you're seeing here at 1.82 terabytes. Again, I remind you that this was last year's process here that's documented in this file. And then after I did this last year, the next thing I would do is a resize 2FS and on the volume, and that went ahead and resized the volume. And when I would do the sudo on VG display, it came back and told me that I had 0 free blocks to expand into, which means that now it was occupying all 1.82 terabytes of the drive. So the addition to this file is this note down here where I talk about the fact that I used Clonezilla instead of DD. So obviously, when you're cloning these drives, you always have to clone from a smaller drive to a larger drive. The problem is that when we ended up with the newer, larger 2 terabyte drive, of course, it looks like the geometry is that of the old drive. And so after copying it, it was supposed to have an option in Clonezilla that said it would resize the partitions on the fly. Everything I read said it should do that, but it didn't actually work. So the reason I think that it didn't work was because Ubuntu Server is not just using simple ext4 partitions, but rather it's using LVM partitions inside of the ext formatted drive. So therefore, I don't think it really knew about that. The drive, as I just showed you before earlier in the slides, it was looking at /dev/SDC3. Well, when it's actually in the system, it's actually /dev NVMe 0N1P3. So the first NVMe drive, which is the only drive, and then partition 3, which was the partition for the LVM root partition. So when you do a DF to look at it, of course, you're going to see /dev/mapper /ubuntu -vg -ubuntu -lv, as opposed to seeing a indicator for the 1p3 partition. So unfortunately, that was not allocating that size, as I mentioned earlier. So, of course, I'm booted from another OS, and after I ran Clonezilla, I went ahead and grabbed myself an Ubuntu Live CD. I booted from the Ubuntu Live CD, and then after doing that, I went ahead and did a sudo e2 fsck on that partition just to make sure that partition was okay. And then I did a sudo resize 2fs on /dev/nvme 0n1p3, and that went ahead and made that ext3 partition, which is really actually an LVM partition, larger. And now I was able to do the LV extend to use 100% of the free space on the LVM partition, and now this command actually functioned the way you would expect it to do. And so now that the LVM partition was large enough, we now have to have the LVM file system large enough too. So we do a resize 2fs on /dev/mapper /ubuntu -vg -ubuntu -lv, and that went ahead and resized it. And then when I did the vg display command, I had a display similar to what I had last year when I did the other conversion. So you'll recall that the primary purpose of this Ubuntu server is to operate as a LXD server. And when we had performed the LXD init, as we did in LXD step by step, one of the things that we said was we wanted the storage pool to be a ZFS storage pool. And if we do a zpool list command, you can see in this particular case that that storage pool is 186 gigabytes. I'm currently using 107 gigabytes, and I still have 78 gigabytes free. In August of 2022, I did a video entitled LXD ZFS Storage Pool Too Small, and here are the notes from that particular presentation, and it shows how we can take a storage pool that we initialized with LXD and how we can enlarge it. We need to find out where our default storage pool is stored, and we can do that with the sudo zpool status. And you can see here that it says that it's stored in var snap LXD common LXD dis default.img. Before we can enlarge the ZFS file pool for LXD, we have to make sure that all the LXD containers are stopped. In order to perform the expansion, we will actually have to do a LXC stop --all to stop all of the LXD containers that you currently have running on your server. To verify that they're stopped, you want to go ahead and do a LXC list. And we can see here that they're all stopped. In order to expand the pool, the first command we have to do is a sudo zpool set auto expand equals on, and the name of the pool is default. The next step that we want to do is we want to execute the command to put the pool back online, and we're going to do a zpool online-e default and all the way down to the file path for the default pool file. And finally, we want to go ahead and execute a zpool set auto expand equal to off on the default storage pool. And finally, we want to go and do a sudo zpool list, and you can see that we have now a 686 gigabyte zpool and a ZFS storage pool, that is, and now we have 578 gigs free because we have expanded it by 500 gigabytes. And finally, we're going to want to bring all of our containers back online, so we can do alexi start -- all, and it should start up all of our containers. So in summary, I did not address using the features of LVM to expand the drive space or expand it onto other drives. And the reason is that the mini PC I was using had space for only a single M.2 NVMe drive. And I had a spare 2 terabyte Samsung 980 Pro that was available, and I wanted to use it. So this exercise shows the flexibility of working with file systems in Linux. Anyway, that's it for today. Please subscribe and like the channel, and don't forget to hit that notification bell, and we'll see you next time.